Look at a coffee bean, how tiny it is. Now grind it. The single grain is hardly seen. A dust particle would be still 10 times smaller than the grain. Compare a coronavirus, it is 50 times smaller than the dust particle. What could be even smaller? A hydrogen atom? Let us see. Whoa! It is 6,000 times smaller than the coronavirus. What about the single proton inside this atom? Actually, we are not sure, but at least it is 100,000 times smaller than the atom itself. Ridiculously small. Now, would you believe me if I say that the 92 billion light-year wide universe started 13.8 billion years ago with a size much, much smaller than this proton? If you like to know how this became the most accepted theory about the origin of our universe, then join us in Sci F3, where science is fact, fiction, and fun. Episode 8, Part 1, The Big Bang Origins. How the universe started, and when, where it came from. These were basic questions in humanity mind since the dawn of history. Religions along the history had an answer to these questions. They mainly said the universe was created at a certain point in the past, so it has a start, and at a point in the future it will have an end. And what have a start and an end is consequently finite. It came also with a favoring for us humans over the whole universe, as we have a noble purpose to fulfill. This gave humans an impression that their planet and its solar system have a central location in the universe. These principles, more or less, present the view of religions and their believers about the universe. In the 16th century, Copernicus, a mathematician and an astronomer, considered no significance for the planet Earth location nor the solar system in what is known as the Copernican principle. It stated that the Earth is not the center of the universe, and that as observers we don't occupy a special place. Since then, the idea was wholly accepted by scientists and is an assumed concept in many astronomical theories. In the same century, the static infinite universe, where space is neither expanding nor contracting, was first proposed by the English astronomer Thomas Digges. A century later, Isaac Newton was hit by his famous apple. This led him to present his gravity law, and with it, the concept of static infinite universe became a necessity for the overall universe stability. Since then, it took 3 centuries until 1915, when Einstein introduced his revolutionary theory of relativity to challenge the static universe concept. Einstein equations held within the science of an expanding universe, but Einstein couldn't take the hard step to adopt an expanding universe concept. He was like most scientists at his time, completely influenced by a static and infinite universe principle. Einstein had to add a constant to his equations to compensate for the universe expansion, and called it the cosmological constant. in what he called later as his greatest blunder. In another place, Georges Lemaitre was a Belgian civil engineer who served as an artillery officer in the Belgian army during the World War I till 1918. After the war, he entered a seminary and in 1923 was ordained a priest. He was fascinated with physics, so he studied at the University of Cambridge Solar Physics Laboratory in 1923 and 1924. Then at the Massachusetts Institute of Technology, Cambridge in 1925 to 1927. He then became a professor of astrophysics in the Catholic University of Louvain. Lemaitre studied Einstein field equations. He could see what Einstein has ignored. The equations were describing an expanding universe. This meant that the universe was denser and hotter in the past. Lemaitre followed the universe back in time to a point billions of years ago, when the universe must have started from a very dense, very small, and very hot point. He called this point the primeval atom. He presented his theory in 1927. His hypothesis rocked the cosmological world that time, as it turned down the well-established static infinite view of the universe. Also, Lemaitres' religious background as a priest did lay shadows that he was attempting to find a scientific base for the religious creation story of the universe. Though Lemaitre was not alone in this approach, as similar views were presented by the Russian Alexander Friedman, the American Howard Robertson, and the Englishman Arthur Walker, still many others were skeptic about the primeval atom origin of the universe. Ironically, the Big Bang term itself, later attached worldwide to this theory, was first time used by the famous astronomer Fred Hoyle in 1949 during his BBC science program. He said in a sarcastic context about the theory, "Earlier theories were based on hypotheses that all the matter in the universe was created in one Big Bang at a particular time in the remote past." In 1950, at the same program, Hoyle said the idea was that the universe started its life a finite time ago in a single huge explosion, and that the present universe expansion is a relic of the violence of this explosion. This Big Bang idea seemed to me to be unsatisfactory even before detailed examination showed that it leads to serious difficulties. He clearly declared that the idea of the universe having a start and it was from a primeval size is pseudoscience, little different from trying to justify the existence of a creator. Even Albert Einstein told Lemaitre when they met in 1933, and before he later confessed his greatest blunder, "Your calculations are correct, but your grasp of physics is abominable." In another context, Einstein described Lemaitres' logic in his theory to be a mystical and subversive way of thinking. Poor Lemaitre. He had to receive all this doubting and sarcasm. He commented one day, "It's not always easy to be taken seriously when you are wearing a cassock." In the contrary, he should have been taken more seriously, for formalizing the most accepted and proven theory about our universe origin and how it developed to the vast state we see now. While this all was happening, an astronomer called Edwin Hubble was slowly collecting astronomical evidences about the universe expansion. Every galaxy he observed was receding away from us, and the farther the galaxy was, the faster it was receding away from us. He developed the Hubble constant, allowing calculating the universe expansion speed at any point in the universe just by knowing its distance from our planet Earth. Hubble constant equals 20.66 kilometers per second for every 1 million light-year distance. Please refer to episode 2 and episode 6 part 1 for more details about his findings. Though Edwin Hubble measurements were considerable support to Lemaitre theory, there was always one question open. If the universe started 13.8 billion years ago with such overwhelming start, where are its signs? Where we can find them? The answer came after few years. On May 20, 1964, American radio astronomers Robert Wilson and Arno Penzias discovered by chance the cosmic microwave background radiation, the CMB. It was simply the ancient light that began saturating the universe 380,000 years after its creation. It appeared to be forming 10% of the noise we used to see in our old TV sets when there was no program to receive. Both astronomers received Nobel Prize in 1978 for this discovery. Please refer to episode 6 part 3 for more details. After this discovery, many scientists looked more seriously into Lemaitre's hypothesis, which was known now as the Big Bang theory. In the coming part of this episode, we shall follow how scientists could trace the history of the universe back to when its age was just a tiny fraction of the first second, with precise details, and guess what, with measurements too, using the CERN Large Hadron Collider LHC. Thanks for watching, and see you in the next part.